Okay, so in this video, we're going to talk about how to solve a proportion. So if you stick around through the entire video, you're going to have a real good understanding of what a proportion is and how we solve them. But along with proportions, generally, we also study the topic of ratios and rates that kind of goes along with proportions. So I'm going to hit on those topics as well. So you should have a real good understanding of this topic, and I'll try to get through the concepts as quickly as possible to give you a really good fundamental understanding of how to solve proportion problems. Before we get started, I do a ton of math videos, so if you like my teaching style and look for additional math help, you might want to consider subscribing. I hope you do. You'll find a lot of additional material. And if you're looking for more formal instruction, complete lessons, notes, tons of solved problems, you might want to check out my courses in my TabletClass Math Academy. I'll leave the description to all those courses in the description of this video. All the links will be there, so if you're interested, you can check out those particular courses. So with that being said, let's jump into this. So how to solve a proportion? Well, first of all, we want to define what a proportion is. So we can't, really understand how to solve something unless you know what this word means. So when we're talking about proportions, we want to talk about a few other words as well. So let's just go ahead and write these words down. So one is a rate, another is a ratio, and then lastly we have a proportion. Okay, I don't want to say that incorrectly. So here we go, right? Rate, ratio, and proportion. So generally, again, when you're studying this topic, you're kind of studying proportions along with these other two words. So you're going to hear these words frequently as well: the rate of something, the ratio of something, etc. So let's talk about these two words here first: a rate and a ratio. Okay, so basically, a rate and ratio, they're essentially just fractions that you right off the top. Okay, so let's just write something here. I'm going to write a couple of fractions, and let's see here. Okay, so fractions. So if you're saying, well, they're just fractions, why don't we just call them fractions? Why do they have special names to them, rates and ratios? Well, I'm not done yet, okay? The key difference is we need to look at what they're measuring, okay? So a rate is a particular fraction that has that is measuring something, and the deal with the rate is the numerator and the denominator of this fraction are measuring different concepts. For example, I could have 30 over 2, but I can have 30 miles, okay, over hours, okay? So in other words, I can have the fraction 30 miles per 2 hours. So a car went 30 miles for every 2 hours. Notice that the units of measure here are completely different. 1 miles is distance, right? And then hours is time. So when you have a fraction and the numerator and denominator units of measure are completely different, okay? They're measuring different things, you have a rate. I'll give you another example. Let's say I have 5 gallons per minute. Now you'll see rates often given the units of measure will be like this little slash right here. So that's gallon per minute. The per is a fraction. I could also write this way, gallon per minute. And you're saying, well, I thought the number was supposed to be a fraction. Yes, you could write this as 5 gallons over 1 minute, 5 gallons per minute, okay? So let's say you have a pump and you're pumping out water out of your swimming pool or something like that, right? You're saying, well, how fast does that pump go? Well, it goes 5 gallons per 1 minute, the rate of something. And when you hear that word, you kind of associate that with like speed, right? What's the rate of the time? What's the rate of this machine, etc. Okay, so let's move on to ratio. Ratio is basically the same idea. However, the units of measure are the same. So let's look at this example here. Let me just actually erase this. Let's say I had one teacher for 20 students. And you might be saying, well, those are different units. The teachers are not students. Well, no, we're counting people. So what we're counting here is the concept of people. So go back to rates. Rates, we're counting what? We're counting distance, all right, which is completely different than time. Okay, here a teacher is a person, and so are students. Okay, people, persons, whatever you want to think about it. Okay, they're still human beings. So one teacher per 20 students. Again, the fraction bar, we usually use the word per. Now, when it comes to ratios, let's write this over here. Per, we hear that word associated with rates. With ratios, we often hear the word to. Okay, so one teacher to, and that represents the fraction bar here, 20 students. So if you have a classroom of 20 students, you have one teacher to 20 students. Okay, that's the correct way of saying that. Now, I don't want to go any deeper than this into what a rate and ratio are, but it's really important that you understand the difference between the two, because it's going to be applicable here when we start talking about proportions. So what is a proportion? A proportion is essentially two equal fractions. That's it. So for example, 1/2. Now I want you to think of another fraction that is equal to 1/2. Something easy other than 1/2. So maybe let's say 3/6, okay? Or 4/8 or 5/10, anything, right? So if I have one fraction that's equal to another fraction, in other words, the fractions are equivalent, then that is a proportion. That's the definition of a proportion, two equal fractions. Now, because fractions, specific type of fractions are rates and ratios are specific type of fractions, we can also define a proportion as two equal rates or ratios. Okay, so that's how this all ties in. And generally speaking, proportion problems very often involve dealing with rates and ratios. Now, I'm going to go ahead and demonstrate something here that's key to what we're going to need to solve any proportion problem. Okay, so this is like the crux of how to do these problems, and that's something called the cross product. The cross product. Now here's the deal: when you have an actual proportion, the cross product, and I'm going to show you what that is here in a second. This times this is going to be equal to this times this. So let me show you, okay? When I use the word here, let me just write it out, cross product. Okay? This cross part of what I'm saying is I'm multiplying this way, okay? I'm kind of crisscrossing like so. And product means the result of multiplication. So we solve proportions using the cross product. So here I have highlighted in yellow. I'm going to multiply this way. So 1 times 6, all right, is going to be equal to 2 times 3. You understand that? So 1 times 6 is 6. 2 times 3 is 6. Okay? So in a proportion, the cross product is equal. So if you have a valid proportion, the cross products are going to be equal to one another. So oftentimes when you're studying this topic in school, your teacher might say something like the following. Let me go and erase this. They'll say, is this a proportion? Is this a valid proportion? So you would say, you would have to verify that using a cross product. So you would say, okay, let's see here. Let me go ahead and test and see if it's actually a valid proportion. So I'm going to get 1 times 6. Is that equal to 2 times 2? 1 times 6 is 6. 2 times 2 is 4. These are not equal. Therefore, this right here is not a proportion. Okay? So that is the key thing to understand about proportions. And of course, rates and ratios are going to be very typically involved when you're dealing with proportion problems. That's why I brought them up. But one last time, the proportion is two equal fractions, okay? A valid proportion. This isn't, but if you have a fraction equal to any other fraction, this is a proportion. Okay, so hopefully you got that down. Now let's go ahead and actually take a look at a couple quick problems. And this topic gets pretty involved. Proportions and rates and ratios are extensively used. So, really, I'm not going to be able to cover everything in this video, but you're certainly going to get a strong foundation of how to solve a proportion problem. Again, you want to check out my full courses or additional videos, etc. But let's get into a couple quick proportion problems. So something nice and easy. Let's take the fraction 2/5 and let's make a proportion. Let's say x over 8. Okay. So I might tell you, solve this proportion. Solve this proportion. And what we're trying to do is solve for this value x. So I'm telling you this is a proportion. I want you to solve it. So all you have to do is employ the cross product. Okay? So I'll show you how this works. So this is going to be 5 times x, which is going to be 5x is equal to 2 times 8, which is 16. So to solve for x, I simply divide both sides by 5. So I get x is equal to 16/5, and I'm done. Okay? So if I was to plug this in up there, the 16/5 for x, I would have created a fraction, although it's a complex fraction, in other words, a fraction involved inside of a fraction. These two are going to be equal. Okay, that's what x is equal to. And maybe this is a little bit more of a, maybe not the smoothest, more easiest example to take a look at, but hopefully you understand, right? I'm telling you that this is a proportion, so all you have to do is use the cross product and solve for the variable, and you're done. Okay, very typical, basic type of proportion problem. Let's take a look at something like this, maybe a little bit more involved. So let's use 2/5 is equal to x plus 1 over, let's say, 7. Okay, so let's take a look at this proportion. So we're going to do the same thing here. We're going to look at the cross product. And when I do this, you have to be very, very careful when you have a proportion, when you have an expression like this as x plus 1. When we multiply, this is where students get themselves in a lot of trouble. They'll go, oh, okay, that's going to be 5 times x plus 1. They'll write it this way. Anytime you see an expression in a fraction like this, x plus 1 or x minus 1, anything that has a plus or minus, always put parentheses around it, okay? And I'll show you why here in a second. So let's do the cross product. 2 times 7 is 14, and then 5 times x plus 1, I write it like so, okay? That's 5 times x plus 1 with the parentheses, because I have to do the distributive property here to solve this. So that's 14 equals 5x plus 5. Now I'm going to subtract 5 from both sides of the equation. And here I'll get 9 is equal to 5x. Okay, so let's go ahead and continue to solve for x. I'm going to divide both sides of the equation by 5. So x is equal to 9/5. So obviously you're going to have to know how to solve other types of equations when it comes to proportions, but you hopefully get the general understanding. Now I brought this example in because this is a very common place where students mess up. They don't put parentheses around these expressions, and then they end up setting up the cross product incorrectly. Okay, so be careful about that, because I've seen this problem many times. When I say many times as a teacher, and there's teachers out there who have been teaching longer than I have, 40, 50 years even, but I've been teaching decades. So I've seen literally thousands and thousands of problems from students. You see the same errors over and over. So when I emphasize something, it's just coming from experience, right? It's like, hey, you have a high likelihood of misunderstanding this because so many other students do. And when you have your teacher, if you're in school and are emphasizing something, like, pay attention, because they're talking from experience, So anyways, be careful when you see those type of problems. All right, now let's take a look at another quick type of proportion problem. We'll take a look at 2 more here real quick, because I don't want this video to go too long, but again, you can see there's so many different varieties of proportion problems that you can have. So let's say I had a scenario like this. Let's say our car went 30 miles in, let's say, 2 hours. Okay, how many miles will it travel? Will it travel in, let's say 7 hours? Okay, so now you're saying, well, this problem, you don't see the proportion. Well, now you have to set the proportion up. So when we're solving a proportion problem, okay, you actually have to create the proportion. So you're going to have to set up a scenario. You have two equal fractions. Okay, so you got a fraction, numerator, denominator, numerator, denominator. Now, if your proportion is involving a rate or ratio, you have to get the units of measure correct. So in other words, they have to be the same. So in our fractions, if I want to put miles here on top and hours down here, I have to have miles on top over here and hours down here. Let's go ahead and see what I'm talking about. So if I have a car that goes 30 miles in 2 hours, let's just build this out. That's going to be 30 miles, okay, per every 2 hours. Okay, so this is one fraction of my proportion. So now I'm going to go ahead and create the second half, but of course there's some unknown here. So I have hours, so I have 7 hours right here, okay, because hours are going to be in the denominator. So I want to know how many miles it's going to go. So that's distance, right? That's in my numerator. So once you have this set up, I can simply just use the cross product to solve. So this is going to be 2 times x, which is 2x, and 30 times 7, which is 210. But let's get our calculator out. Even myself, maybe it's because of my age, and I work with numbers so much that guess what? I don't even trust myself to do calculations. You might think that's counterintuitive, but I've learned to double check myself because I avoid problems. Okay, so you're like, wow, you should be confident in your mental brain capacity, and I am if I'm forced to, but I always triple check, and you need to be doing the same as well. Okay, so anyways, we have 2 times x is 2x. 30 times 7 is 210. So to solve for x, I just divide both sides by 2. So 210 divided by 2 is going to be 105. So x is equal to 105, but 105 again was where the miles are going to be. So that's 105 miles. So this is a very typical type of proportion problem right here. Okay, you won't be given the actual proportion. Like they're not going to give you the setup. Your teacher is going to be looking for you to build these fractions. Okay, let's take a look at one last quick other example where you might see a proportion. And let's see here. I'm just going to show you generally what I'm talking about. We may not even actually complete a problem, but I'm going to show you where proportions come in pretty handy. Okay, so let's see here. 3, 4, 5. Let's see here. So let's see, 8. All right, hopefully this is going to work. I think this does. Okay, so if I say you have two figures that are similar, okay, so in geometry, when you have similar figures, or if I tell you, hey, these figures are in proportion, you would see this symbol right. This means similar. Means that essentially you have two shapes that are not the same size, however, are in the exact same proportion. Okay, this is the word similar in geometry. Very, very important concept. I like to teach it in this manner. Let's say I have this shape, okay, and then you just zoom in or zoom out. Like I magnify it, right? I make it bigger or smaller, and the bigger or smaller version of this, although it's a copy of it, it's just a bigger or smaller copy of it. It still has the same angles. The sides are still in proportion. Okay, so if you look here, I have 3, 4, 5 as the lengths of this triangle. If I just double everything, I have 8, 6 and 10. So these two triangles here would be in proportion. But let's suppose I wanted to know what the length of this was. If I said these two triangles are in proportions to one another, how could I solve for this length? Okay, so remember this was 3, but let's say I gave you this problem here, solve for x, solve for this missing side. Now you could use the Pythagorean theorem to do this if you know what I'm talking about, a squared plus b squared equals c squared, but I'm giving you two shapes here, all right? And this is very oversimplified problems, but you'll get the idea. So what we're going to do is compare two sides. I'm going to compare this side of the triangle to this side, and these two same sides are these sides, okay? Do you understand? This is the longest side to this side. This is the longest side to this side. This is what we call the hypotenuse. And I'm involving the missing variable. So let's just do it this way. 5 over x, which is this side of the triangle to this side, is equal to what? 10 over 6, okay? So let's go ahead and actually solve this particular proportion, okay? Because I set up because these triangles are similar, they're in proportion, I can build this proportion in this manner. So I just use the cross product again. I have 5 times 6 is 30. Let me give myself a little more room. And 10 times x is 10x. All right, so now to solve for x, I just divide both sides by 10. I get x is equal to 3. All right, and that's exactly what this was, if you recall, before I started this problem, before I made this an unknown. So you oftentimes will see proportion problems in geometry with figures, and it doesn't have to be triangles. You can have all kinds of figures that are not triangles that can be in proportion. But if you're told that the figures are in proportion, then you can use the concept of proportions by setting up equal fractions or equal relationships and then using the cross product to solve. Okay, so kind of covered a lot of ground. There's tons more of examples that you need to understand. Proportions are extremely important in mathematics, so you have to master them. So if you feel like, oh, okay, you understood these problems, well, that's just the basics. Okay, you really do need to work on practicing this stuff more. So let's go and wrap this up. Again, I hope you enjoyed the video. I hope you consider becoming a subscriber. If you do, make sure you hit that bell notification so you get my latest videos. And if you enjoyed the video, I'd appreciate a thumbs up. And leave me some feedback. I do get a lot of comments on my videos, which I'm grateful for. But it lets me know how I'm doing and gives me ideas on what I can do for you in the future in terms of math help. But if you're in an immediate need of a lot of formal math instruction, something really even much more comprehensive, and you like my teaching style, check out my various courses. I'll leave the links to them in the description of this video, and they're pretty effective. I offer much more than what I do in my YouTube videos, although I try to do high quality videos on YouTube, but unfortunately I can only cover so much in a block period of time, and I don't want students to get overconfident. They're like, oh, because they understand this, then they have, that's everything they need to know. You really do need to practice this stuff a lot to be masters of it, and that's what you want to, be shooting for. Not just have a basic understanding, because that's only going to get you so far. You want to really truly master this, and proportions is a extremely important topic in mathematics, so you should be striving to look to really, get this down. But with that being said, I definitely appreciate your time and have a great day.